We are recording for session number 5, so it's going to be a little bit of repeat from build technique, but then we're going to get into Wiki taxonomy and collaborative literacy. So how do we collaborate? It's about integrating both the on-site and off-site collaboration. Builds, support of build means all kinds of information work that can happen elsewhere. We get to the presentation. View. Slideshow.
Okay.
Okay.
It's your phone.
Do we have anyone? Not exactly, but we'll record anyway. So this is recording. Let's take a look. So, organization of information on a wiki is it's like the wiki contains all the work that we do over the history of the project. There's about 20 years of work on it. The wiki itself started back in about 2007. So I mean, we've got almost 2 decades of info. And now with the computer age, you've got things like large language models that can now parse things like wikis and generate sense out of it. So the wiki relies on, like Wikipedia. Our wiki uses MediaWiki, same thing. It relies on numerous contributions. Anyone in the world can get an account and you can edit. It's basically open book publishing, just like Wikipedia, which, after all, Wikipedia has knocked the pants off other things like Britannica. I mean, Wikipedia is the #1 website in the world. It's a lot of people go to it for information. Now, with the advent of artificial intelligence, I think there's some reports that Wikipedia is going down. Numbers of people are just looking at things on artificial intelligence or ChatGPT or whatever they've got.
Yeah,
but
it's really pulling information off of sites like Wikipedia, undoubtedly.
Yeah, because the AI parses it and it can
Yeah.
make sense for you, and that's why it's quite useful. So what does taxonomy refer to? So on a wiki, because there's so much info, in fact, I mean, there's thousands of pages. If you're a savvy user, you can actually find thousands of pieces of information on the wiki. Specifically with the Global Village construction set, you've got 50 machines. I talked about the process by which we develop machines, which is module-based design. We break them down. We break down machines into the smallest parts possible. You can go into a dozen. You can, in fact, go into the parts of modules. So you can have like 100 different parts you're developing. As long as you know the basic breakdown of various machines, you can be effective in developing any machine, because any machine starts with industry standards that you take by studying what exists in the world and moving on to develop similar counterparts. But the breakdown, it's pretty common. It's like a human body is made of cells, chemistry is made of atoms and things like that. Machines are made of certain parts, and once you get that kind of understanding, you will be able to do that. Like in all of the work we do, things that are common are things like, well, frames, power units, controllers, other things, electronics, etc. If you know that kind of organization, then you can find information. And that goes into the whole topic of taxonomy that starts with, so if we have 50 machines, we got a bunch of modules, and we develop them in concurrent time. If we have people, if there's, I mean, the challenge so far in the project has been getting the large masses of people on board to develop things. But at this point, I mean, we're not there yet at all. We're starting the apprenticeship, and it's rough. We're doing the builder crash course. Hey, a first person sign up for the November builder crash course. Sign up, people. So we already put that up. Thanks, Bikram, with the website. We put a little link. Sign up for the builder crash course, etc. That's going forward. Let's actually look at on the taxonomy page on the wiki to talk about taxonomy. So if you go to the wiki, let me share my screen here for the remote viewers. Okay, remote viewers, taxonomy discussion. I'm sharing my screen, entire screen. Share it. Do we have it? Yes, looks like we've got it. Taxonomy. What do we find under taxonomy? And how does this relate to the framework? When we talked about rapid learning with information technology, the wiki is actually one of those accessories, like a notebook, which actually can extend your brain because you can organize stuff virtually, and then you can have agents like AI, parse it and actually try to make sense for you. So it's an extension of relating to the rapid learning process. And imagine if you had at your fingertips the designs, blueprints, everything, how to do. You can pull up anything from the design and build. Like say you want to build something, you want to build an object, you want to build a toaster, you want to build a washing machine, you want to build a car. I mean, imagine those designs were existent. Yeah, you can download if you have fabrication capacity, you can build that. Now the big missing link, of course, right now is that we're trying to address is, as I said many times, is the absence of high quality distilled design, because all the best stuff is proprietary. Every 19 years, you can say that when the patents run out, you have like a turnover, if you think of it that way, a turnover where over 19, basically what people learn or have access to is literally like 19 years back, because all the 19 years of patents are still, you just can't get to it, meaning you're less efficient and you don't have the best access to everything else. If you have a wiki like an extension of your own brain and you can find anything, that's a great boost to your productivity as a human towards distributed economies that we talk about here, as opposed to centralization. The knowledge is all over the internet, spread far and wide. In fact, they send this up into space already with, there's some of those satellites that are in space. What is that thing? I forget what it's called, but our wiki has been uploaded into space too. Like there's this one satellite, this open source satellite that if like the internet fails, there's this one satellite that beams down open source content, and our wiki is actually one of those pieces of content and things like that.
Okay.
So if the world ends, there's hope, but we only have 2% of our stuff done. We have one absolute complete product, which is the house, 50 more to go. So no, we're not far yet. So let's talk about taxonomy, how to do it. Module-based design, I mentioned that we break things down. Machine naming convention. So the 50 things, if you know their names, and we're developing what we call them, some of the most important machines in civilization, if you know their names, you can look at that name, and we have a list. So how do you orientate yourself on a wiki? There's a spreadsheet including modules, but what's the master list? You have to start with a master list. This spreadsheet here actually is a GVCS module spreadsheet. So you have basically like all the different machines listed, but that list is available on the wiki. So if you go to the wiki and type in, for example, CEB press, you get all the CEB press, right? What happens when you don't know the name of a machine? Well, go back to the taxonomy page. But this kind of awareness is like once we're going and going along in the project, when people are developers, they learn what we're working on. Like for example, the seed eco home. There's be a whole genealogy and.
But you said the house was the only one that's finished. But I mean, you finished the compressed earth brick press. I mean, it's right.
See, we did, but who's using it right now? I know there's been about a dozen or 2 dozen builds around the world, but nothing like a business or a viable enterprise has sprouted out of it, meaning that it never went to that final level of product development that allows it to escape the confinement of kind of one-off builds. I mean, not like it's not documented, but what it tells me is that it's still difficult enough, and the whole ecosystem is hard enough, and it's not accessible enough to the point that people can just crank it left and right. Like for example, we don't have a torch table, so if you want to build this thing in one day with 12 people, I mean you can't really. It'll take you a week because you got to do it all like drill holes with.
Then you think that's some issue with the design for it to be adopted like that? You mean
that too? Including, so even though we have a machine that you can build for $5,000 that the nearest competitor would cost about $50,000 for that performance, that requires skill. Because you got to do hydraulics, you got to do fabrication, you got to do electronics, controllers. So it's not easy, and it's not like with the house, we have a product that we're actually selling on an open market.
Yeah.
And that's the ultimate validation. If we have a store online where you have CB press for sale. I mean, right now we can do it still kind of like these beta releases for early adopters. Like, for example, some dudes from an eco village, Kakwa Eco Village, they'd like to build a CB house. They want a custom workshop, but it's kind of this one-off territory where, like right now, kind of what we're doing with the workshop, where it's the first build of that particular house, it's hard. And until you clone it and make it smooth and easy to replicate, it's brutal work. It's like right now. I mean, right now it's actually a difficult workshop because we didn't have the full level of refinement, like, for example, with the CDECO Home 4, which allows us to do it much more efficiently. So there's that huge difference, and it's kind of hard to catch because that difference it's subtle because you think, oh yeah, we've done it, like people replicate it, but you got to really say it's like whether it's this basically DIY thing versus literally commercial production, that either you're producing it or anyone can start that business, and it starts to replicate in what we call distributed market substitution, which means that that kind of product begins taking over the market, because if it's better and more refined, it should. That's kind of what Linux did, right?
Well, what if somebody had a business where they rented the compressed earth brick press to people that wanted to build a house? So it's like, well, okay, well, I want to build one house. Okay, well, there's the machine. We'll rent it to you, and you can build your house.
Absolutely. That would be a business in itself. But once again, yeah, I mean, somebody has to build that machine, maintain it for a lifetime when it breaks or whatever, and things like that. You got to have some equipment to load. Cause, I mean, this thing would require about 50 people to load by hand. So, but you need one tractor to do that. 50 to 100 people could keep up with a tractor. But I mean, it's intense amounts of soil that you're moving through this. So you've got to have this infrastructure. You probably have.
Well, that'd be the thing. Rent a skid steer too. Well,
Yeah, and it's all doable. And it's an excellent kind of an enterprise. It's effectively what you're talking about is public sector enterprise where you have access to the productivity and the machines and the technology to build things that you wouldn't be able to.
Yeah.
I mean, tool rental things like, Belt Rental and St. Joseph, I mean, they're kind of like that. I mean, it's typically just for plain commercial work, like people, like contractors will get their skid steer out there or whatever. And of course you can do that for many things, but their pain point is once again going to be what I discussed about the treadmill ROI thing, that on their machines, the lifetime is 5,000 hours before people kind of throw them out because they're too expensive to repair. Engine pops or whatever, just very expensive repairs that you're literally getting a new machine instead of keeping up with the repairs.
No.
So the advantage here for the open source route is you can introduce the concept of lifetime design, where this does live forever and it serves more needs than we think.
Mm-hmm.
Back to taxonomy. The ultimate, I mean, there's things like modules, so each machine you can break down into modules. And so, for example, if we have a huge list, like we got 50 machines, like say 10 modules each, then, I mean, what's the deal here? The concept is modular breakdown to allow work breakdown structures that allow huge teams to participate. Our goal is to get many people, like Linux, has when Linus Torvalds first developed Linux, it was like by the time he had about 1,000 developers, that thing went nuts and took over the world, you could say, perhaps. But that was a few years into the project. But you're not doing this with a few people on and off. I mean, we're still at that stage where it's a few people on and off. It's like, okay, it's 2 full-time people on site. Now we've got a project going on. You got 10 people, you got 20 people, you got 50 people for a workshop. But it's very much seasonal. It's not stabilized yet. So you need those numbers, and part of that is gaining the ability to distribute work to many people, so that because the global village construction set is very much impossible to do by 2028 without any kind of breakdown and ability to distribute a lot of work. Like, for example, right now we've got a group called Gaia from recent collaboration with students from Cornell have a group that they're going to do a design competition on the skid steer. So they're going to collaborate on that and get people from MIT and UCSD and all that participating on it. So we get more effort. And for that, you have to be able to. I mean, the whole deal of taxonomy is, at the end of the day, where do you put it? How do you track it? How are you going to continue to develop this? And that's why we use the wiki as a universal catch-all. Of course, there's GitHub, and that's great for software, and you can use all the kind of different tools. But because MediaWiki is such a robust platform, you can have pictures and all kinds of information. You can embed things. We use that, and you can do templates and all kinds of. Once you have the information on the wiki, you can parse it. You can index it, and at the end of the day, you can know where everything is. So, for example, if we're going through the program of Global Village, the apprenticeship, at the end of 4 years, my goal is to be able to teach anybody how to pick out about 100,000 pieces of information within seconds. So you're talking about, okay, machine, version, say we want a new biodigester, we're actually producing gas and running cars with compressed biogas. Okay, you want to do the next iteration of the thing we did in 2025. Okay, well, you have to find it. You have to find the version. You have to first know that the biodigester is a thing, that it's part of the housing ecology. So the biodigester, say, could be a module within a housing construction set, right? So that's where you got to break down the thing into as many modules as you can. So then you can go through the 40 or so development steps. And the other answer to your question about the CEB press or the 3D printer, we actually have sold 3D printers as kits, and we ran workshops where people take one home after a weekend build. But I'm losing myself. The taxonomy of development steps, which let's go through that. We'll go through that. Then you can actually go through all the steps for a viable enterprise, and which is like the next level. And now how I define the final status of completion, I said kind of, we're like 30% complete with designs. Yeah, we've built and prototyped them maybe once or twice or thrice, but as far as that product release stage, like the CD home, man, that's where we got to get to, because otherwise our experience over the 20 years, it's like, yeah, you do all this work, but where's the viral replication? No, it doesn't happen. So our goal is to refine it to that point.
Well, there isn't anybody that's making money on the 3D printers. I mean, like doing custom stuff. Hey, I need a whatever printed, and they print it.
It's huge opportunity. Alexa is the closest to it. She's working on it to actually produce parts. Like, we'll involve her in terms of for example, the tracks for the bulldozer, the skid steer. We're going to actually attempt to do tracks if possible. If we get enough people. I mean, the wheels are the low-hanging fruit, but if we get enough people, you can 3D print tracks in small parts. They'll be like tank tracks. If you examine how a tank track looks, it's these elongated sections that are joined with pins next to each other. So that's the kind of model we could do. We could do rubber, and then we could do pins, metal rubber composites, thermoplastic urethane kind of thing. Was there a question or? Okay. Let's go through the actual. So there's versioning.
Can I ask a quick question?
There's development spreadsheet. We'll go through that. Yeah.
Are you when you talk about like seed eco home 4 and then 5 and then 6?
Yeah.
Is that like each time you build a home, like this is the 4th one we built, this is
Yeah.
the 5th one we built, this is the 6th one? Are you gonna like iterate like, okay, this is seed eco home 6, and then there's 20 of those out there, and then this is model 7, and then there's 20 of those out there?
Yeah, and how we're gonna do it is right now we took all the way up to 5 is the build in Savannah, 6 is this one. We don't have a 7. So whoever builds the next one, we're going to call it 7. Because if it is a direct fork of our work, along all the techniques, and it's actually contributing to it, I mean, that's part of us. It's like if somebody replicates that and builds that and adds value, I want to use it. I want to make more money. I want to make a better home. I want to teach people how to run a business with that. So it's literally our own versus defection, when somebody might just completely like use our stuff but completely shift it so it's no longer lifetime design. They'll put some proprietary component in there and hide the design. It's like that's a defection, and that doesn't get us anywhere. I mean, how does it help? It doesn't promote the abundance culture, because a lot of times people make those forks and close them up because they get greedy and think they can make more money with it, where our perspective on that is, no, if you want to make more money, open source it, because then that's the real robust model, like Linux has shown. And where it is about meeting needs in a better way and providing better product for real, as opposed to like what companies say that we've got the best. No, I think it's kind of we're in a stone age of innovation. So when we talk about development spreadsheet, so this is what it is. There's a whole. This is like the most critical thing. So if you got 50 machines, we go through 40 development steps and 40 enterprise steps. Let's look at those development steps. What does it look like? I mean, it's pretty simple, but it's like we had this we were embedding Google Docs, but then the other day I showed you how you can just do let me show that again, but this is already embodied in the wiki as a template. So for example, if you start a page, if you want to do CD Home 7, and this is like, Brad, you're going to go back, you're going to actually build a house you're going to replicate the 720 square foot. That's going to be called CD Home 7 if you're doing what we did and building upon it. So let's do Seed Eco Home, not 6, but 7. Whoops, it's already taken. Okay, so taken, but let me go 8.
You did that the other day.
I did that the other day.
The templates,
So we're just creating a placeholder for CD Home 8. It doesn't exist, it hasn't been built yet, but it will be, so we might as well do it now. But to create it, all you do is the wiki has a template thingy, double brackets. If you hit double brackets, that calls forth a template that's been defined before, and the template, it's simply called dev. There's another, so dev, and I'll show you what dev is. Dev is we program the wiki, and this is why the wiki is so useful. Instead of my log, I go to template colon dev, and it actually shows how that template is made. This is actually wiki markup. Oh, thank you. This is wiki markup. So the template looks like this in wiki syntax. It's like you got to format it, but when you call that template, what it does, so I'm calling the dev template and pipe, so you pipe in, meaning you pass into it whatever it is, and it's going to be CD Eco Home 8. With a dash, we use a dash there, Eco Home.
This is just
8.
HTML, right?
This is it's not HTML because it's actually wiki syntax, media wiki syntax, which it can use HTML in there,
Okay, good.
but this is actually media wiki template syntax.
Because you
similar,
can
but
use
it's-
both.
It's similar.
not
It's similar,
compelled.
but it's like
You could do-
language.
You could
I
do
You know, but it's
HTML,
similar.
you could do CSS in the wiki, like when you're editing. But look what happened here. So I just seeded. So if I save that, save page, there it is. I already seeded it, right? So now if I do the requirements here, you know,
Whoa.
we need. So that's how you start. You got
you're
20
talking about
steps.
That dev. The dev did this.
That one dev seeded this whole template of 40 items. That's called a template. That's the power of templates. You just call some template and you can
But
pass.
how do you know the names of all these templates? I mean,
Because
not
I
how
created
you
it,
know,
but
how
then
would I
but
know?
then you go to templates, wiki templates, and it'll probably. So wiki, if I go to a page called. Oh no, let me just go to whatever.
How do you know these useful
So
messages?
templates, it'll talk about what templates are.
No,
so
I
here's
just
the
have,
discussion.
Like, the dev on there.
How do you do it? So overview. To make formatting or other repeat information show up on the wiki, it's used to do shortcuts such as template, whatever. And there I just called the template directly, but this is a whole, I mean,
Wait. Stop.
there's a bunch of stuff here.
Developer
There's
template.
wiki
There it is,
templates.
right there.
Yeah.
Video script template, OSHW dashboard template.
Like
Well,
OSHW dashboard, what's that? See, like if you, yeah, for example, like you can call up the dashboard and it will give you all this templated and formatted and graphics in there. So templates are infinitely powerful. Like if somebody creates templates, you can now, for example, template, CD Home workshop, and that would seed all the information like, okay, team members, here's the CAD and whatever. Like it'll seed all the information there for you, etc. Very useful functionality. Go back to actually, let's take a little look, because when we develop stuff, people are like, what do I do? Like, I don't know what to do here. Well, you can do like 40 different things if you know how the general concept of product development works. So if you study product development in college or whatever on your own, they'll teach you, like, what do you do? Well, you got to start with requirements, etc. There's a formalized, I'm not inventing any of this stuff. This is all old school. We call it open source product development because we're working on open source products. And we kind of adapt some things, like, for example, like bill of materials. For us, we like to do visual bills of materials where you just hyperlink and click on parts and like a visual representation of something, how it's made. Why? Because we like that. We think it's really useful. But then you can go through all these steps. So whenever you start a project, you got to go through requirements and value proposition. Like, okay, so what? Why are you doing this? Okay, I'm building a CDCA home because I want to provide people an opportunity to build a home for $40,000 instead of buying one for $400,000. So you start that, and then you might say, well, the value proposition is ease of build or starting an enterprise, and you can define as much, you can go into that as much as you want. And then for requirements, you would do things, well, it's got to be open source for us, it's got to be lifetime design, it's got to be easy to build, it's got to be swarmable, doable with machines or just by hand. Like, there's all these properties that we do, and those requirements are a whole extensive list. The values that we have are called OSC specifications. So there's like 100 items. Like, over the years, I just granularly try to break down all the different values that we put into when we start a requirement for anything that we build. So this is a huge list. Core values. So we embody, so the list, and you can go through this in detail, but absolutely open source, collaborative, inclusive, modular, distributive economics, low cost, simplicity, user friendliness, DIY, closed loop manufacturing, high performance, industrial efficiency, ecological design, resilience, anti-fragility, systems design, substitutability, robustness, design for tolerancing, multi-purpose flexibility, best practice, complete economy, freedom from material constraints, renaissance skill sets, scalability and fractality, village scale, non-violence, amicable social contract, community and family needs, proven techniques, sufficiency, new economics, flexible fabrication. You can go on to like 75 only. But these are the properties we stand for, like scalability, lifetime, you better believe it, transcend and include, design for disassembly, exponential design which could scale, distributive economics, systems design, economic significance. We don't work on LED blinkies, we work on GPS, RTK, GPS tractor controllers. That's economic significance. And so we pass on all those values, and then you can have a requirement. So somebody, when they understand the specification, they can go all out, pedal to the metal, and define a very detailed requirement. And the interesting thing about, like, if you go into enough detail, the requirement, the CAD, the build instructions, core things, bill of materials, if you have a complete requirement at the very limit, so limit as the thing goes to infinity, like in math, what's the limit of a requirement? If your requirement is so specific, then you have actually produced a design. See what I'm trying to say? So what I'm trying to say in this multifaceted approach of swarm, design, and build, anybody can approach the problem from, like, people are like, what do I do? Like, I'm bottlenecked. No, you're not. If you understand the process, you could do 1,000 things, and etc. So if you work out the requirement, you can say, well, the modules must be 4 feet wide and use standard dimensional lumber pre-cut studs. Well, then you've already literally given me a bill of materials with which I go to Menards for. I know I have to get a pre-cut stud of some sort. Or if it's 4 foot wide, I have identified that, oh, like the top and bottom members in our modules, well, they are 4 feet long, so in my bill of materials, I better have a count of some 4 foot long stud members and things like that. So let me go another way. What if I'm doing CAD? CAD is a very important step. Oh, okay. Well, if somebody, so I'm talking about how you scale a process to multiple tasks at the same time, because we want to leverage the collaboration of everybody. Just like on a build, we're struggling to see, okay, what can I do? Like, you know, you're looking for things to do, and a lot of people are watching. A lot of people might be like, oh, I don't know what to do. Show me what to do. But once you get this kind of common understanding, and which we call collaborative literacy, at an ultimate level, you find that you can do a lot of different things. So, for example, CAD. Let me give you an example. If you have the full CAD, like the absolute complete CAD of that house, including the say the fasteners, whatever, would you not be able to deduce some requirements? Yeah, you can if you think about it. And if your CAD, like for example, if your CAD also has an excellent part tree where you labeled everything, or even your CAD includes fabrication drawings, which are actually a separate step, because that's like more like build instructions. Fabrication drawings are explicit steps, like 15. But if you have the CAD, we just said, oh, well, now you can do all those other things. Well, what if you don't have the CAD? What if you just have the bill of materials? You have a big shopping list of things from Menards. Well, if you have that, you can start generating the CAD. If you learn how to do reverse engineering, to look at a drawing, just start drawing up in FreeCAD. So what I'm trying to say is that in the limit of infinity of this process, you can actually derive each step. If you go into enough detail on any steps, you'd literally be able to fill in all the others. That's why I'm saying, like, once people understand that, then people can see that, oh wow, we can completely collaborate seamlessly, but there's a huge level of understanding that one has to have about the process in order to succeed at that kind of a thing. So that's the thing. But to go through it, we start with requirements, value proposition, industry standards. So what has the industry done to date? What's a skid steer? Well, we talked the other day that it's pretty degenerate in design. It's like they all look the same. Okay, well, if we're building a skid steer, why don't we just try to copy it? Once we find other things that we don't like, we'll modify. And we already are putting in our own components and designs like power cubes for scalable power, which a regular skid steer cannot do. We can, for example, put a loader arm on the back. We've done that with one of our tractors. We can put another power cube to scale power. It's all of that. We can be flexible, but we start with industry standards. We study what's been done. Otherwise, you're just reinventing the wheel. You don't want to go completely from scratch. You kind of, like, once you know industry standards, that's when you go from scratch. You can just sit down, meditate, or at the beach you can start drawing out your cool design. But it helps if you know industry standards. And industry standards is something you can study from the mainstream system. And you learn a lot of that in college. And of course, you don't learn the best stuff. You just learn like the superficial level of that in college and engineering class. You just learn principles. You don't learn any like actual designs of real, commercially feasible, economically significant, as in one of the OSC specifications, designs. You don't really find those. But okay, conceptual design. Once you look at industry standards, you can have a whole analysis like what kind of scan all the different manufacturers. How do they do things? What was different? Why did they do it this way? What are their cost structures? How do they fabricate? Look at their manufacturing. That's industry standards. You can study all of that and get a great idea for how then you go about building your own. So then you do concept. So now you start getting conceptual design. And as I said before, you can get, like if the concept is to make a thermal battery house, like an off-grid house, well, you probably in the requirement, you already had something like, oh, we've got circular economies and autonomous design and things like that. So you already have that in there. I'm just trying to tell you that there's a link, like one step is linked to all the others in a pretty intricate way. Module breakdown. If you have a concept, okay, I got a concept, I think it works such and such. Start breaking it down so that if you have a team, many people can develop it at the same time. if you define modules, you have to define interfaces, how they fit together. Like you can't just tell people, just do this, like do the loader arms, and you do the wheels, or you do the frame. You have to tell them how the loader arms attach, how do the wheels attach. For each one, you have to define interfaces. It's called interface design. But interface design, we don't have that explicitly here, but it's under module breakdown. If you click on that, now if you have interface design, man, like that is so related to requirements and value proposition, because if the requirement is modularity and lifetime design, all those good things, then you better define clear interfaces, easy to work with things that can snap in and out. You know, that's what interface is, that you have clear boundaries as opposed to like this big hairball where you don't know where one thing begins and where the other one ends. I mean, that's how people design things right now. It's all like, it's not modular. So we like the modularity value because, I mean, with this hairball design that the current system does, it's, you know, that's where you have the big junkyards and big landfills, but that's not a sustainable system. It's just bad design. I mean, you know, there's feedback like, yeah, we're polluting our environment and trashing a lot of stuff, using 10 times more resources than we need to because we throw them out instead of keeping them around. 3D CAD, that's obvious. That's super important. If you've defined you can start 3D CAD as the first step too. You can just start doodling. And like if, for example, you know that the wheel, like you saw a skid steer and you actually measured it with a tape, and you can actually replicate a good example of the wheel. And if you have a 3D printer, you can print it, for example. I mean, so you can do various steps. Like Suzanne, you're saying you can do some things in parallel, some things in sequence. Well, at the limit, you always try to look for more ways where you can parallel things as opposed to sequence. Especially when you have former models or former work, you completely don't sequence. You can start at a particular step. Calculations, yeah, that's a whole lesson on that. I'll do another session on calculations, like how do you figure out things like, okay, how vertical do you have to be? How much lumber do you have to have there? How much is that nail going to hold? Just basics of steel, plastic, and wood. Those are like main things. There's ceramics, steel, wood, plastic. Those are kind of like the main materials in civilization. Electronics design. If electronics design would really be, in this house, it would be the power center, all the powers, or some house automation and things like that. So this is kind of this general template, but for electronics design, you might say electrical for the house or something. Wiring and plumbing. Well, wiring and plumbing definitely applies to a house, but I mean, completely applies to a tractor. Like, how do you plumb the hydraulic lines? They go in certain ways because we use hydraulics. And wiring is, yeah, you have to keep your wires not in a messy hairball, but organized well so they can be serviced and easy, transparent to troubleshoot. Software, if you have software like the brick press had software, simple code to make it run. Bill of materials, standard bill of materials, and there's requirements for how you do a proper bill of materials. If you click on bill of materials, you'll get into what is a proper bill of materials. It's not like, screw, give me a 2x4 piece of lumber. Is it treated? How long is it? What's the quantity? What's the lead time? You can get very detailed on a bill of materials so that there's no question. Like if somebody says a 2x, well, what is it? Is it fir, spruce, pine, SPF? Is it cedar? You gotta get very specific. You can't just blurb out something like, give me an Arduino. Well, there's like 100 different types of Arduinos, right? So you have to specify Arduino Mega, whatever, or this or that. You got to be specific. Define some of its properties. Like for screws, you're gonna obviously put length and whether it's exterior, interior. Nails could be interior, exterior, shanked versus smooth, zinc coated, not whatever you got. You could have plastic fasteners. You can have steel or stainless, whatever. Visual bills of materials. I really encourage this as a really rapid way to learn things. It's such an effective way. Oh yeah, like for example, that's a visual bill of materials. Every single thing is hyperlinked. So if you want to build this, you don't guess what that thing is. It's that. I mean, this saves you so much time. You could either study the system, for days, or you could literally get out all the parts and click on them and order them in 5 minutes. In fact, that's how I do ordering. I'll just, okay, I got to build this, click, 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 Amazon, Menards, Home Depot, and hit buy. So instead of this taking like, it's a week project, I got it in a day. In an hour, I clicked on all the parts. And this because it's all already shows you what every single part is. You're not guessing anything. So you can put this together in a few hours, as opposed to a week project. The standard design would be where they just do it on the fly. They just figure it out. So if you start to standardize things or do visual bill materials, and now this one's actually like that's for hot water, like hydronic heating, which is very hot, for like subfloor heating, for example. Now with the water system in a house, it's actually way easier because you got shark bite fittings. I'll show you that later when we do that. But that's the visual bill of materials. CAM files, computer-aided manufacturing files, you can get them right out of the 3D CAD. So for example, in FreeCAD, you can export STL files for 3D printing. If we want to build the tracks for the tractor, you get them right out of the CAD, export to STL, slice it for the 3D printer, give it to the 3D printer software, it prints it, bam. Or you could do things like two-dimensional cut files, like if you draw out, so CAM files, what are some?
CNC machines?
Yeah, computer-aided manufacturing, any CNC machine, 3D printers, CNC torch table. And here's some basic guidelines. You can use LibreCAD, FreeCAD, or Inkscape to generate DXF files. You can there's various ways to do it. You can study various ways. I don't have too much info there. But for example, for the brick press, we cut, or the tractor, like tractor wheel mounting plates, you cut all that out on a torch table and then weld. And it makes it super, super rapid. Like, how long would it take you to cut out a wheel plate for a tractor by hand? I mean, it's hours. With a torch table, you do like 5 minutes, because it's like 20 inches per minute. So a thing like this, 20 inches of circumference, that's 1 minute, and then the holes, it's like 2 minutes of cutting on a torch table. Whereas by hand, you got to measure, mark, cut. It's like an hour, probably an hour or two. And then you might have to go back and correct it, and then it takes you 2 or 3 hours instead of 1 hour. So that's CAM files. Cut lists. So cut lists are very useful. Like for the, for the house here, we could have had a whole cut list of parts. Here's all the dimensional lumber, all the parts labeled OSB, and then you're just setting up somebody to just manufacture. You don't need to then take the CAD or bill of materials and try to parse through what I need to cut. Cut lists are very important. So that's bill of materials related. The first was all design related. Then there's build and data,
Marcin,
and also background research.
Do you have to do each one of these individually, or does it parse it out automatically if you do one piece and then it gives you all the rest of the pieces? You know what I mean?
Like, what do you mean by that?
Like if you do the CAD drawing, does it give you automatically
Oh, yeah.
the CAM and the cut list and the BOM?
It depends.
Or do you have to do it individually?
You might have to do it individually. Depends what features you're using within FreeCAD, the latest version.
Yeah.
I'm not sure what all it has, but we have already done things like, there's all kinds of hacks you can do. Like, to give you an example, with the bill of material, with the CAD file, you've got the part tree. Imagine if you simply labeled every single part very accurately. You can do that as a big team. If you got a lot of people, that's a tractable task. You have Suzanne's class takes the house and labels every single thing in detail in the part tree of that big file. Which Katerina did it. She labeled it in a basic way. It's not super accurate, super detailed, but if you have an absolute, for example, a 52-inch long 2x4, whatever, one simple way to do, FreeCAD already has a spreadsheets workbench where you can just simply say, oh, give me all those parts from the part tree, and there you have a spreadsheet of all the parts. And you can give that, and that spreadsheet, you can start automating that, like in ChatGPT, you can tell it to, okay, now give me a proper bill of materials with a number of quantities for it will count it up for you. So it can do automated or semi-automated workflows within FreeCAD. The cool thing is you can program that to do it automatically. Like you can probably program it to tap ChatGPT by now to say, okay, and now invoke ChatGPT to maybe in its FreeCAD's got a programming workbench like on the bottom as a command line in Python as well to do things. But yeah, FreeCAD is just so cool because it's flexible. You can completely modify it. Like if it doesn't, what you just said doesn't exist, then you talk to a programmer and it will exist tomorrow. That's the thing. Because you can program it, you can then upload it, and the whole world has it. So some of those things are super worthwhile doing, and slowly FreeCAD gets better. I think it's going to take over all the other competitors because it's such a really powerful. I mean, CAD is such a well-defined, powerful thing that it probably will take. I'm pretty sure over time it will be the industry standard. I think that's my opinion. Okay, build parts. Test-driven prototypes. So what's test-driven prototypes? You, instead of building out the whole tractor and waiting at the end to test the tracks, you start doing it. You start somehow maybe do a simple thing like even a little scale 3D print. That's a test-driven prototype. It's scale modeling. Do I have a separate one for scale models? No, I don't. Prototypes could be of all types. They could be scale models. They could be just take the hydraulic gear down and put it on a measuring device, or make a measuring device to see, okay, how much torque do you have? Or just take data like over 5 hours it heats up like this and then stabilizes, whatever. Take data. That's all data that's relevant. Instead of building the whole machine and then waiting, okay, we're just going to field test it, you can get data for individual parts, and that's called test-driven design. It's a very important part of a formal development process because then once again, with the modularity concept, you're not waiting till you have the whole thing and then you've spent all that energy doing it. It's really part of the second Toyota paradox where they do excessive prototyping. They push the test-driven prototypes to the max and they build out only at the very, very late end stage. Like a regular company might build like one prototype in 3 months and then do another one, and then in 2 years they have a final car. Toyota will do like, no, just give me all the prototypes. We're just going to build it once because we're going to figure out all the details. And it's an effective way to do it if you know how to do it. So definitely recommend that. Build instructions. That's the absolute obvious, that you got to provide detailed build instructions. Like right now what you guys can do is take the editable docs, the kind of presentations I do in the morning, or we can actually be editing that. That's part of this collaborative design process where we're all contributing to a document. Like you guys built it now. Like I don't have to write that. You're going to say, okay, do this, do that, and we can collaboratively, all online, you can edit it together. So one person doesn't have to do it all. And I guarantee you, one person will never, ever do it. It's too big a task. And I say the documentation part is even bigger, more effort than the build itself, if you're going to provide all that info, because it is. It's just how it works. Build instructions, quality control checklists. So someone might define, okay, in this, as part of build instructions, you can add a checklist for things like, so like Suzanne, for example, told me, hey, the floor is bowing down. And Susanna actually fixed it, and that completely got that module down. That was great. So that could be a quality control checklist. To the next build, we say, well, next time we'll make sure we add more blocks to the foundation there. Or like, whatever, do the flat pad and that's finely graded. So quality control point, take a long level and measure that your floor is flat and it doesn't have like a 1/4 inch bow. You literally had a 1/4 inch space underneath it when you span across the module with a 6 foot level. Great, quality control point. Another quality control point. Are there any nails sticking out the other side? Check for that. And you can have a dedicated person to do that. You can have a person doing nothing but that, going through a checklist, making sure everything is good. We all do all of that at the same time, and we can formalize that process much more as we go forward. Fabrication drawings. Those are the dimensional drawings, and there's a particular way you do them. You want to organize them in a way where you have X, Y, Z views, like the front view, the top view, and a side view. That's like, you can't go wrong with it. I know in some of ours we just had one view, then some other angle view, and you couldn't really relate it.
Well, yeah,
let's
that's what made it
stick.
confusing on some of the wall modules that you couldn't tell.
You couldn't tell.
Which-
I couldn't tell.
Yeah.
So Katrina and I were talking
But
about that.
yeah, on those, I don't think it was an advantage. I think there should have just been one view, and we already know it's made out of 2x6s. So I don't think you really need the other views on those.
Yeah, but in the top view, you will not see some of the things that the side view can give you. Like for example, if you have that box, that C box in a wall module,
Yeah,
from
I
the
can see
front it
that.
just looks flat. But from the top, you see, oh, that's that D shape. So you need to have it.
I can see that.
Yeah, so you do the front, top, and side,
Yeah.
and with that, there can be cases where the geometry is so complex that you can't even tell it from there, and therefore you have to make extra steps, extra descriptions on your blueprint. But a lot of times with like these wall modules, I don't think there was anything that was not absolutely clear after you did the front, side, top, including there's an option in FreeCAD where you do transparent lines so that you can see what's behind that, like as if the object were transparent. So the thing that exists in the front is a thicker line, but you see lines as if there were objects hidden behind that front thing. So that's the show hidden lines setting in FreeCAD when you generate those those drawings. Visual fabrication diagrams, what is that? I would call that a visual fabrication diagram. Here we show how we put these pieces together. Then we put this top on it. Then we put these guide rollers, these shafts, and these other blocks to get this. This isn't a diagram. It's a completely visual diagram. These are just screenshots from FreeCAD. Or you can have some other crazy things like this. You know, you start with the sides, blah blah. Now you make the frame. Other person makes the drawer. Other person makes the cylinder, hopper, blah blah blah, and then you've got the finished machine. So I mean, this could help a lot. In one view, you've got here's like an overview of all the steps. So this kind of stuff can definitely help. And this is like in a development spreadsheet, it's the visual fabrication diagram. We hardly ever get to that. I mean, it takes effort. There's like a lot of work that goes into a single diagram like that, but that tells you like the amount of condensed information you can present, and then you can probably with better computer infrastructure or more advanced logic, like in FreeCAD, you can program it. Okay, give me an automated fabrication diagram generator. Yeah, you can do that. You have to give it rules for how you do it, okay, and stuff like that. But all this kind of extensibility is part of the FreeCAD package. You can do extended in whichever way. Exploded parts diagram. Well, actually, FreeCAD has an exploded parts workbench, so you can do things. Oh, this is not an exploded part diagram. What I'm referring more to, there's an animated, exploded part. Well, that actually is. Exploded part diagram is where you're like labeling every. I mean, this is a technical drawing. It borders on exploded part diagram if you actually, the focus of this is to label each part by what it is. So that's kind of exploded part diagram. But exploded part animation is what I was referring to. I do have that as a separate step, because if you see something blown up as an animation, and FreeCAD has that, yeah, that's a good learning tool. And to generate a really high quality, I'm telling you, if you do a really high quality exploded part animation, perhaps that will be like, man, you can generate so many other assets from that. Well, in terms of your understanding, you obviously would have had to have the CAD before you do that. Or maybe you don't have the CAD. You have a conceptual CAD, which is not the actual dimensions, but you did that in Blender and you published it. Well, that's still super useful for somebody to get oriented, even though you don't have the true underlying CAD, that you can't take the fabrication drawings out of that. So, you know, there's all kinds of angles you can approach this problem from. Language agnostic instructionals. This is when our quality has been perfected. We need a language agnostic instructional for how to build this house. What are those things? These are things that are self-explanatory. Like, I mean, I have a instructional video on it, but this is, you know, we did this kind of a thing. I'm trying at a language agnostic instruction where I say, okay, we labeled these parts, these are CNC cut parts, this is how we make frames. You know, it doesn't have a lot of language. It has some language there. But you try to get to like where you visually, because people can parse things visually pretty quick. Like I can say, oh wow, okay, that's the whole thing at the end. Cool. And these are all the pieces that come together.
Language
Well, if
agnostic,
you
like it doesn't matter what language you use to convey
you could be
it,
Chinese
or-
and you can look at this and you don't need the text. You can probably read like the part numbers, like F21. Say you've got a pile of parts that are labeled F1 through F30 and whatever. Well, you just take them. If you take F2 and F4, you can put it together with F1 and F2 to make this frame right
so
there.
That is IKEA. They don't have any
It's IKEA,
words.
yeah.
Yeah, it's like
Okay, got
So
it.
the other name for language agnostic instructionalists is IKEA style diagrams. Yes.
that makes sense.
Parallel production engineering. So here's where you actually think about how you break down the workflow. And I think about this a lot. That's why whenever I'm out there, it's like, my first thing is like, why are you standing? Why aren't you doing this thing? Because I always think, like, my mind is already thinking, here's like a few steps. But what do you do there? You have to, if you can define, like for example, with the house that we're building right now, you have some diagrams, visuals, which show teams and different tasks all at the same time, like what can happen all at the same time. It could be words, it could be diagrams, but you can't just shut up and not say anything about it, because then it just means that somebody's doing a completely sequential process without respecting the fact that you can do it in parallel. But you have to think about it and define it. You have to sit down, and it takes effort, but once you get, and you have to have a lot of people, right, because we're designing for swarm workflows. But we like that because we're trying to get a general literacy in people for how to design and build things. Our comment here is the general philosophy is we cannot have a just world when people like don't know how to build nothing. Like you got to be able to build certain things, because otherwise you are so dependent upon the manufacturing sector or the political sector for your existence, that your index of possibility is so reduced at that time that you get depressed all too easily because of that. I think there's no power like the ability to build your reality. I mean, that's the most empowering thing. So I think democracy, I don't think we can have democracy without more people learning how to build things and fend for themselves. Like right now, there's a lot of deprived and a lot of social ills out there. A lot of that is related to the complete loss of any kind of fabrication literacy or productive literacy in the society at large. I mean, I definitely see it. I mean, there's people that know how to build things. There's people that don't. I see that. I do observe that the people who are the builders, they are just so much more optimistic and just have more possibility around them. They kind of emanate that. So data, build pictures. People, where are all our pictures? I gave a link to the common folder. Try to click on it. I have uploaded just a few things in there, but build pictures. Upload them to a common repository. That way we can keep track of all the things. Like, for example, I took a picture of that bowed floor with a level underneath it, and then the before and after of the wall, literally just dropped down that like 1/2 inch to 3/4 inch after the floor was leveled. That's build pictures. And we've got 30,000 pictures for the CD Go Home 4, so you can go through them. And I'm not kidding. So build video, yeah, Barry's doing some of that. We can study that. We can actually, if you've got time lapse, you can actually study the game, like what you did, and see if how you were doing, and you can assess that. Build data collection, how big was that module at the end of the day? Take a picture of a tape measure, like if it was the 20 by 12s, take a tape measure of a tape with it, because you're not going to remember tomorrow, like, was it a quarter? Were we like 1/16th on? Was it like 1/8, 1/4? What was it? Was it under? Was it over? You don't remember any of that. So take pictures and take videos, and that's part of realistic data collection. It's a powerful thing. Performance data collection, yeah, all kinds of things. Review, so we could involve other people. Like if you know any engineers or house builders, ask them, or any people who build houses like this, which there aren't, so we can't ask too many people. But if you have a carpenter, you have some pressing questions, I mean, we try to get feedback, but it's not that easy because like the professionals don't give you feedback for free, and a lot of people just have a lot of ideas without having built a lot of things. So getting feedback is challenging, and that's where actually identifying open source minded people, collaborative people who do have high skill sets, but are also willing to work and share it. I mean, one big block is an engineer will just not do it if you tell them you're going to publish it openly. They're like, oh, it's too much liability. They're just not going to work with you. There's blocks, simple blocks like that. But so that review step is actually quite difficult. We had an inspector actually comment on our plumbing and electrical, whether it was code, for the CD Go Home 4. So we got a little bit of review, and he basically said, no, this is all legit. He wasn't a plumber, but he was the inspector, so his word actually is probably worth more than a plumber. We asked all the things we were doing with the vents and the pipe size and bends and all this and that, is that all legit? And he said, yeah, that's okay. So we know we would have passed it. So then we go to the actual build inspection, and because we had that review, we know that we're actually going to pass it, and we're not going to have rework, because we reviewed our design, reviewed at every step. Review your CAD, review your build, review your design, review your data. Like, somebody could look at data and say, well, this actually doesn't make any sense, or be like, wow, this is good. I mean, you can review just about anything, like every single step in this process. Future work, so you set yourself up for, now you got some data you want to see. Future work is to streamline the process. Obviously, you might make some milestones, like when it took us 20 minutes for that first wall section, how are we getting it down to 10, or how long should it take, by realistic estimates that can help you track everything. Bug tracking, so how do you do a bug tracker? I mean, there's bug reports. We have a thing called a review form on our wiki. Like, if you see something that's wrong, you can just submit this. We just have a simple spreadsheet. But in GitHub, for example, we've got formal bug trackers that show this code is bad here, and then here's an issue, and so forth. So different software might have different ways to track bugs. There's a bug tracker in the form of each page on a wiki actually has a discussion. I don't know if you know that, but each page has a page and a discussion. So there's nothing in the discussion there, but you can in principle leave review and feedback or bug reports, right on the comments section of each wiki page. Some people comment on wiki pages and they review them.
Marcin,
Troubleshooting and repair.
do you want to let people go one at a time to get a burger?
Yeah, sure. I think I'll go through the rest of this. I won't cover more since we're like getting close to an hour. But troubleshooting and repair. Like, once you have a machine, you have to tell people how to repair it or troubleshoot it, because you've learned obviously through that build tons of things. You want to communicate it. Otherwise, a person is starting from scratch trying to figure out how to fix something, how to make something work, or whatever. You document all of that. So that's part of the data collection. It's kind of like, it's not really the build. It's like after you build it, like when you're maintaining it, we're kind of put it in a data section right there. Now there's also background research, another section we used. How does this product fit with other products? Like, if this is the house, how does it fit with a lumber mill? The lumber mill makes lumber. So you can come up with various kinds of product ecologies around all the different things, to like, the solar economy, like all the cyclic material flows. You can define all kinds of ecologies of what flows to where and how it relates, whether it's in disciplines or with actual machines. Like, I like to draw up various things like, this steam engine, which is really no longer a steam engine, but an engine unit. It actually powers your cars, tractors, and machines, or generates power or heat or whatever. So it's product ecologies that you can define, which then make for the idea of construction set design, where you're designing whole product sets, not just one thing. So for example, with a CEB press, like, the product ecology around it is so important, because you have to have the tractor, you have to have the soil pulverizer, probably some conveyors, so a way to dig and quality control the soil, which means a soil mixer. Like, without a soil mixer, including sifter, I mean, to do pro grade CB, where it's actually you could either sell it or have really replicable or even stabilized block, the quality control that goes in there is a whole process. It's like a mini plant, you know, conveyor belt, sifting, sieves, pulverizing the soil or whatever, or adding dosing cement into it if it's stabilized. So
So you're
that
doing
whole
like
product
a half a
ecology.
dozen different machines or processes at least. Too.
Yeah, if you're gonna do it where you're say selling brick or
Yeah,
you know
on
actually doing
scale,
replicable
basically.
housing at
Yeah.
scale, or you could do what we did. We just take the soil pulverizer right on tractor, we go through the soil and load it directly in a brick press, and then people take the blocks out, stack them in a house. So that's like that actually has a lot of power. If you can design your process where you use just a simple machine with like raw soil, the bricks are going to have more imperfections, but it doesn't matter because they typically have 300 psi anyway at the minimum.
Okay.
Between 300 and 700 psi, which is codes require 300, and we easily get like 500 to 1,000. You know, so
And the only
it's
thing
like
you'd
we're
have
already good.
The only thing you'd have to watch on that would be moisture, huh? Right?
Yeah, if you got too much moisture, you're gonna be not even able to press bricks. If it's too dry.
In the future, in the building, yeah. that
Oh
they're not
yeah,
getting
and that's why the
rained on,
workflow for that would be let's build a roof first and then be safe, because if you're building that over a week, I mean, single rain, you lost your bricks if they're not
Yeah.
stabilized. So
Right? Yeah.
so if you're doing it right in the wild, yeah, you could. I actually like the idea quite a bit. Create the roof structure, fill in your walls for free after that in a safe environment safe from rain. That's a great idea. Now you still have to insulate. There's huge thermal mass there, but product ecologies is where it's
Yeah.
at. So if you define it, you're just expanding your thoughts about how you're going to design the thing to be more interoperable, more diverse, and more flexible in its overall design. Like I want to definitely make room for like the back loader arms on a skid steer. So if you want to do 2 implements at a time, I mean, because the one pain point about the skid steer is just like one implement. You got to switch them all the time. Extra power, yeah, absolutely. Or a thing like, say it's a huge thing on a front, it's got its own power unit. All kinds of extensions. So there's a product ecology there with extra power cubes or extra other machines, and so you
Yeah.
just want to think about all of that. And then, of course, OSC specifications. I already talked about OSC specifications a little bit, all the properties we use, how it works. It's important to define, so how does a tractor work? What are some of the key mechanisms in there? If you can help define that for people, they're going to have a much easier time starting to design it.
Tractor works by feet, squirrels run, tractor move.
Yeah.
Yeah. Tech tree of choices. So when you start a problem, there's various ways to solve a problem. So, like for example, what's that say? Hydraulic CNC axis. Like we're actually looking at, how do we build CNC machines that use hydraulics instead of electric motors? So I said, well, you have a choice of using hydraulic motors. You have a choice of using cylinders. Maybe you have these other things. So you explore all the options across the board for when you got to build a skid steer. What are your choices? Like for one, it could be a tracked skid steer. It could be a wheeled one.
Did you ever do anything that was PTO powered, or you went?
Yeah, we had. Well, PTO, that's a hydraulic motor with a PTO shaft. Okay. We did that, and we ran a baler with that. Okay. We ran one of our first tractors. In fact, the bales for this house were done with our tractor and a commercial baler. We powered the baler by a hydraulic PTO motor we put on our tractor. So, for example, on a skid steer, I would want to put a hydraulic PTO motor output, so I could run other things. Now, I don't particularly like that because it's you can get wrapped up in the shaft. That's why we use hydraulics. Like we actually are deliberate about not using, because people die. There's like probably 100 people die each year from getting wrapped in a hydraulic power takeoff, the power takeoff of a tractor. So we're actually being careful. Like let's try to put the motor right on the device, never a shaft where you can get wrapped around it and die. I mean that happens quite a bit to farmers. It's not like 100 or so deaths a year or something. Tech tree of choices, different ways you can do things. background reading, like there's seminal books about every topic. Identify those seminal books and write it down. So what's the big deal about that? Background reading, seminal work on a topic of interest. Don't find some trash recent work. Like find the source of something. Like where did this start? Find its history.
Ooh, I've got all those books. They were donated to the school. Like all the original, like actual schematics and stuff like that.
Yeah,
For mechanics
I mean,
stuff. I have so many mechanics books. old
so
school
here,
ones.
yeah. I mean, there's tons of this stuff. So procedure, like, there's a lot of useful links if you want to go through this. But I mean, how to find seminal literature? Search Wikipedia. I mean, there's a thing called literature review. How do scientists find out what all has been done? How do you do a patent search? This could be part of the background reading for this. Background research, yes, I actually put that as a separate thing. Background research and patent search. You can pull up patents and then you can just read them, or you can use ChatGPT, ask it about various patents to synthesize them for you. I actually repeated myself. This is industry standards. Did I? No, actually. Oh no, I didn't even do. I have this. There's about 40 items, and I refined it in a wiki template. It's actually slightly different, but it's pretty much the same thing. Industry standards, I discussed that already. Start with, like, people always ask me, how'd you design this? It's like, all I did was look at what already exists and build upon it. Do that. Technology assessment. So you want to go through evaluating the requirements or OSC specifications, and after you do industry standards, assess them. Like, okay, how do the tracks on a skid steer work for us? Well, unless you 3D print them, they're a really bad idea because they're very expensive, like $4,000 to replace them, and they're very hard to replace. So we say ease of maintenance, ease of repair. Well, that doesn't really fit ease of repair. So you got to do some technology assessment based on your values and requirements and specifications to start refining what you see in the industry standards to look more now like what you're going to build. Okay. And then value proposition is like, okay, so now I study this. What are you trying to do with that? I want to build a skid steer that lasts a lifetime and its operating costs are like $100 a year, like very, very low. That you can maintain it, that it's not an operating cost in your business. Perhaps that's the best single way to represent that. I would like to design and build a skid steer that is not on your operating cost spreadsheet because it's so inexpensive to maintain. Ooh, oops, what did I just say? Ooh, that's actually very hard. So I'd look at product ecology. That includes fuel. Because fuel is a super high, that's the second cost next to breakdowns. Ooh, that means we're going to do, by virtue of product ecology, we're going to have to do pyrolysis of plastic to get diesel and gasoline because that's abundant. We have plenty of that waste stock, and then once that runs out, like we can do that easily off plastics, but in the future we can get that off biomass. So the next, so now because I made that radical value proposition, now I'm responsible to fill all that in, and I mean it. Like I do want to do that, and therefore I think about, oh, I also got to do the pyrolysis of plastic, because otherwise my operating costs are still going to be very high. It burns a gallon an hour, few gallons an hour, probably like at full throttle. You're burning, your operating fuels and costs are like $5 to $10 an hour or so, something like that. If you're running that 24 hours in a day, that's $200. Well, you don't run it that much, but say you run 1,000 hours, 2,000 hours of work per year. That's a lot of money. 2,000 times 10, like 20,000 or whatever. We want to reduce all those things. So when we design a product, we think about all these things, and that's a basic way we design things. I'll quit at that and maybe take some questions for now. Any questions?
Mustangs is a sawmill app.
Oh wait, was that one bumped off? Was I talking to myself, or do we still have the remote viewers? I think we lost everybody. We were
Oh no.
talking to ourselves. Oh, well, we do have the recording. So today was taxonomy and and the product development template, that's like the critical thing of the product, the taxonomy. You've got 40 items there, so and then each of those items can have many sub items in there. So right there we've got 50 machines, 40 items, that's 2,000. Now if you break your machines by modules, that's another dozen or two. So from 2,000 you're already getting into 20,000 items. But if you just know the simple taxonomy, okay, here's all the development steps. If you're talking about you're a developer, you got to pull up anything at any time, or you're a builder, you got to pull up any information. Then you contribute to it, and you got to know where to put it. You can't do it. So how do you do it? Like when you build something, like you literally have to embed your development template. Just start one. Like if you're going to build something, the way this wiki collapsed in the early days, we had a couple of years where it was nicely organized, and then we got the new version. And then things started getting mixed up between the old version and new version, and you never knew what thing would belong with one and another. So we encourage now the simple fork at the end of the day is when you're making a new version, you just copy everything over. In practice, how it turns out is, and that's why we keep like version 1, 2, 3. If I did CDK Home 4, it looks like it's less complete than CDK Home 2. Let me give you an example. Because what I'm doing is I'm passing all the stuff from before still applies. It's the same evolution. So if you look at, just to give you this example.
So you only write down the new info. Like
Yeah, exactly.
Two,
Yeah.
CD Home 2, and then the new info.
Yeah, so for CDK Home 2, we filled out just about everything in there. We have a lot of, look at how the development template looks. You know, a lot of links, right? Whereas if you go to CD, will I pull that from 4? No, that's not it. I have it at SH. I make redirects, like SH4 is redirected. No. Well, it's, you know, it looks like it actually has a little less. It still has got a few, but there's some other ones that if you understand this taxonomy thing, and that's what we do, we continue developing forever until we open source civilization. But what we do in our particular project is if this looks empty and that's actually a product release, well, there must be some other stuff before. So if we, for example, don't have it here, so that's the 4 3D CAD, which is pretty exhaustive, you know. You got all of this stuff here. CDK Home 2 CAD. You might find some other things, like maybe if there was some detail that we did there. You know, it's a little different. It's going to be a little different.
Would it be helpful if I brought it if you needed to do anything in there?
Like for example, this actually has the PV, but we also have that on the other one. Anyway, when the practical ramification here is put all your stuff on it, just start using it. Don't worry if you're going to mess it up. Like that's the main thing. Just first thing, just start a page. Like my new home design. Okay, so it's not CDK Home 4, or it's not a CDK Home thing, but if you're actually trying to build one that's got any traction, so you actually build a real one and you have a lot of documentation, you know, if it's nothing important, then we won't consider it for like the main genealogy tree. But if you build something and it's like a lot of people have built 3D printers, we try to record all of them on the wiki. Just don't be afraid to start a new page. Just embed your dev thing and start, because it embeds all that for you. Even as an impetus for you to start going through that development process, just do it and don't be shy about it. Because like if there's any conflicts for naming, I mean, you can always rename things or redirect things on a wiki and things like that. Like for example, like Bikram's house, you know, it's empty right now. If you tell us like it's all theory, like without you building it, so it's like, oh yeah, great, you know, we've got enough theory. But if you actually build it, have pictures and data and this and that, then contact us and we'll put it into the main so-called main branches. We'll we either link to it or take components out of it and use your modules. So for example, easier way to think about it is like the window boxes, like the new super window box design that gets 5 pounds of tomatoes every year, whatever. Like you came up with some renewable system on a house, and it's just a module. We can incorporate that. Like we could just say adopt it, and this is really nice. We're going to use that in the next version. So that's how it works. We pick and take whatever we like. If we don't like it, it just stays there. It could be on the wiki. It's not taking up. All it takes is bits of memory. It's cheap. So just document stuff with the hope that at the end of the day you're parsing it. AI can parse it. You're going back to it. You're building upon it, so that we have what I described as the time binding concept. You are building upon former work, as opposed to like there's billions of people. How many people are building upon each other's work? There's some, but I mean, it's when you think about it, it's very limited. Like one person goes off in a corner, does something, nobody else hears about it. But imagine if you have that mindset where it's like, well, this is important. If I'm going to solve this for myself, I'm going to solve it for the whole world. That's how we think here. We might as well share it and communicate it and encourage more people to do that, because that generates value. That's true open collaboration.
I agree with that, except I have one caveat, and that is if they are going back and hopefully getting those foundational principles of the why and the how of the design, because when I entered the scene for construction, all I'm seeing is how other people, like professionals, are doing it, and I'm questioning why is it done this way, and they can't tell me, because they learned, it's that whole, this is the way it's always been with the monkeys and the, and the banana hanging there, and they won't let each other go for it because of what happened in the past, but none of them remembers because none of them was there. So there was only a handful of people doing construction that had any idea about the why at all. And they're just like, I don't know, I just do what I'm told. I don't know, this is just how it's always done. Right? And so I'm like, well, why do we do it 24 on center? And they're like, I don't know. Right? And then finally someone's like, oh, it's because OSB is made that way. I'm like, why is OSB made that way?
To be fair, as someone who asks those questions, I'm often told it's not your job to think, just shut up and do it.
Okay, yeah, and I don't. That's a terrible response. Terrible, right? Like,
so the caveat you're making is what? Like when
is if you're gonna stand on the shoulders of giants, understand how they got to be a giant, right?
Yeah.
Like
Oh,
actually
absolutely.
go through that whole discipline. If we haven't learned anything from Jurassic Park, it is that, right? If you're gonna stand on the shoulders of giants, learn the science behind it, right? First.
And are you commenting that whether we do it or not, or are you just saying?
No. I think we should. I'm a huge fan. Like, I've built my whole life on seeking out like masters and the best and people who really know what they're doing, people who know their stuff, right? And like kind of skipping to the end, like, all right, I don't have to reinvent the wheel. I can go to the guy that invented it, right, and just find out that thing. So I'm a big fan of that, but I do still want to know the why behind the wheel instead of just taking the wheel.
Absolutely.
That's my point.
And you do that because you have a brain. That's,
but I'm choosing that because, like, I'm just saying, there's also a tendency to just stand on the shoulders of giants and not
no, you don't want to
care
do
about
that.
the why.
Yeah,
And then
you gotta care.
And then you can't problem solve down the road.
Yeah, that's right. So any other comments or anything? Or do we wrap it up here?
Sorry, I asked one.
Oh, yep, and I did it. I left it in.
All right, so we'll wrap it up. We're hopefully got this saved. And until next time.